Hello my students in grade 6, this is Miss Mary and today we will start a new lesson, lesson 5, States of Matter. Please open the book, page 64, States of Matter. Let's start. How do particles move in solids, liquids and gases? We have 3 states of matter, maybe we took them from grade 1, solid, liquid and gas. And if you remember, we said that all matter is made of atoms or groups of atoms. And these atoms are always moving or in constant motion. This idea is the basis of the theory called kinetic theory of matter. Kinetic energy, if you remember, we took it last year, is the energy of motion. Kinetic theory of matter, it says that particles inside matter, they are always moving or in constant motion. So this is the meaning of kinetic theory of matter. You can highlight the meaning, please. Let's see how do particles move in each state of matter. What decides if the particles will move a lot or no? The amount of energy. If atoms inside they have a lot of energy, they will move fast. If they have little amount of energy, so they will move very little. Like exactly when you have a lot of energy, you can play, you can run, you can do exercises. But when you don't have enough energy, you can't do anything. You feel like you are tired, you will not do anything. You don't have the ability to do anything because you don't have energy for this. And we will see now in each state how do particles move. Let's start with solid. What means solid? Solid is a substance that has definite volume and shape. For example, if you have a book on the shelf, the book will have the same volume, will not change the volume, and also will not change the shape until you change it, okay? The particles in a solid are very close together, like here. When we look here in this picture, we will find that atoms are very close to each other. They don't have spaces between them, exactly like people are sitting here. If you look here with me, you will find that people here are sitting to watch a movie or something. They have a little space between them and they don't move around a lot because they are sitting watching the movie. Exactly like the particles of solid. They don't move freely. They don't move a lot. They just vibrate in their places. They move a little in their places. So the particles vibrate but are fixed in a place. It's fixed. It means that particles here vibrate but are fixed in a place. Okay, they don't move. The particles in a solid are packed together. As we see here, they are very close to each other. They are packed like it looks like someone arranged them to form regular pattern like the one we see here. For most substances, the particles in a solid are closer than the particles in liquid. We are going to say that people are sitting in seats, moving only slightly with their chairs, like particles in solid are closely locked together and they can only vibrate in place. So this is how people here look like the atoms here in the solid. Okay, so now let's move to the next slide about liquids. Page 66. In liquid, particles are not very close to each other like in solid. Particles are a little bit far from each other and they have space in between. Like exactly people here outside, they waiting for the movie. They move freely, they have spaces in between. They are not tightly together, tight, or they vibrate. No, they can move a little bit freely. So a liquid substance has definite volume and no definite shape, because as we know, liquids are always changing the shape according to the container. If you put some water on the floor, they will not have a shape. Liquid will take the same shape of the bottle. So we can't say that liquid has definite shape. No, it doesn't. Particles in a liquid, show here, have more kinetic energy. They have more energy than particles in a solid do. The particles are attracted to one another and are close together, but not that close like solid. Particles in liquid are not fixed. They are always moving. And they can move from place to place, okay? So in this question, how are particles here look like the people here in the lobby? Let's see. People in the movie theater lobby can move around freely. People can move around here freely. However, their motion is limited by the people around them, like particles in a liquid can slide past one another. So people here can move freely, but not very freely. They cannot run or like this because people around them. So, but they can move freely more than solid. Okay. In gases, particles can move very freely. Look here, particles here, they have a lot of spaces between, right? Like outside the theater here, people can move in the street freely because it's empty and they don't have a lot of people to hit them, so they move freely. A gas doesn't have definite volume or shape. The gas takes the volume of the object or the container that you put inside. Like for example, if you break down a bottle of perfume, the perfume will go everywhere inside the room, right? So it will change from a volume of a small bottle to the volume of the whole room or maybe the whole flat, right? So gas, they don't have fixed volume. They can take small volume or large volume. They can expand, or particles can move away to fill the container. And also they don't have definite shape because, for example, we have different balloons. We have balloons dolphin shape, we have heart shape, ball shape. So that's why they have a lot of energy. As we said, if they have a lot of energy, they will move fast, okay? As you can see in the model at the right, gas particles are not as close to one another and can move easily in any direction. There is much more space between gas particles than between liquid or even solid. The space between gas particles can increase or decrease with a change in temperature or pressure. As if you cool it, it will change to liquid because you're taking heat or you're removing energy. So the state of matter decided by the pressure, and if you press on these particles, you will change them to liquid. So by pressure and temperature, states change from one to another. In this question, how are particles in a gas like people outside the movie theater? How people outside here look like the gas? Let's see. People outside of a movie theater are spread far apart. People here are far apart and they can move freely. This person can move freely. Like this atom also can move freely. Like the particles of gas can move freely. Particles have more space in between. And as we notice, we have a lot of space around this person. Like here also, we have a lot of space around each particle. Okay, so for now, we spoke about solid. They have fixed shape, fixed volume. Liquid, they don't have fixed shape, but they have fixed volume. Gas, they don't have fixed shape or fixed volume. Fixed mean definite or the same or constant. Okay, grade 6. Okay, so let's move to the next part, particles movement and energy. In this part, we will see the 3 shapes of particles and how they move. Look here in these particles, they vibrate in their place, right? They don't move freely and they don't have spaces in between. In liquid, they have more kinetic energy and they move and they slide, but also they don't have a lot of space. Look here, they all are in this part of the picture. They don't spread apart, okay? In gas, look here, they move freely, totally freely, and they take all the space. They take all the space around. Okay, so here the movement and energy in each state of matter. Gas has the most amount of energy because they can move freely and they have a lot of spaces. Then liquid, and last would be solid, has the least amount of kinetic energy. If we will compare also between solid, liquid and gases, here we have the diagram. The diagram here shows the arrangement of the atoms. Arrangement here close together and random arrangement. They have random arrangement. They are not regular pattern like here. Look here, they are very organized and arranged regularly. but here they are random. They don't have a regular arrangement. Here they are far apart and they have random arrangement as well. Movement of particles, here we said they vibrate in their place. Here they move around, they slide past each other, and here they move quickly in all directions and they move freely. Energy, here they have the lowest amount of energy. Particles have the lowest amount of energy. Particles here they have medium energy, and particles here have the highest energy because they can move freely, as we said. And here we have examples for each state of matter: cubes or blocks, liquids like water, and gas like in the balloon like helium, like oxygen, nitrogen. They all are example for gases. In this question page 68 and 69, here we need to know each state of matter. Here we have B, so B will be for, yes, will be for solid. The bubbles here will be for, yes, gas. A will be gas, will be liquid. Okay, the water here will be for liquid. Okay, so we need to identify substance A, B, and C as solid, liquid, or gas by placing letter in each of the small circles below. In the larger circles, draw models of the particles of each substance. So we will write the letter here. So B for solid, as we said, C for liquid, and A for gas. And now we will draw the particles inside. In solid, when we draw, we have to draw circles are in the same size and they all are arranged together and they don't have spaces in between, or little spaces, very little. And when we draw them, we have to draw them in regular pattern, arranged. Then we will draw in liquids. They are random and they have a little bit spaces in between. And in gas, we will draw them very far from each other and they move freely. Okay, so what happens when water substance change state? As we see here in this picture, we have the three states of water. We have here the gas in the air, we have the liquid in the water down in the ocean, and we have the solid in the ice. So what happens to the water substance as it changes from state to another? Ice, liquid and water vapor are different states of matter of the same substance. As liquid water changes to ice or changes to water vapor, the water molecules do not change. If we see here, we will find that the water molecule here made from 2 hydrogen and 1 oxygen, and also when it changes to gas, it's still made of the same atoms, 2 hydrogen and 1 oxygen. So the type of molecules that make the three states of matter doesn't change. They all are made of water, and all of them they are made of 2 hydrogen and 1 oxygen in each molecule. But what actually changes in the three states? The motion changes and the amount of space between molecules. These two things are the only things that change between the different states. Like here, they have a lot of space in between and they have little amount of energy. They have more amount of energy. Here, particles, they have a little bit space between them and they can move freely, they slide, and here they are fixed to their places. They only vibrate in their places and they have little amount of energy. So only the motion and the amount of space changes, okay, and the amount of energy as well. Okay, liquid changes to solid by freezing. The liquid changes to solid by freezing. In freezing, we take out energy. We take out energy from the liquid to change into solid. So what happens when liquid changes to gas? Liquid changes to gas by, yes, by boiling or evaporation. The liquid changes to water vapor, and in this case we give more energy to the liquid water to change into gas. Okay, let's solve together the questions here. Melting state, the melting result in a solid becomes liquid. For example, we need to give example for melting, like when the butter melts in a warm pan. When you put a piece of butter in the pan, it melts. So this is an example for melting, and in this case we add heat or we add energy. Freezing, a liquid becomes a solid. Give an example for this. Molten rock when cooled, this. Boiling, a liquid becomes a gas, like water boils, as it's written here. Evaporation, like a puddle dries out. Condensation, when water droplets from one side of the glass, the cool glass. Any cool glass, you will find outside drops of water. This is because condensation, and condensation when a gas becomes liquid. Sublimation and deposition, we will discuss them next video, but also we will speak about them. Sublimation, solid becomes gas directly. When solid, it changes to gas, like the dry ice. The dry ice, when it melts, it changes direct to gas. And that's why we call it dry ice, because it never gets wet. Okay? Like the ice made from carbon dioxide ice, when it melts, it changes direct into gas. Deposition, a gas becomes solid. Like for example, frost forms on a cold window. Okay, so let's solve the question in the book on this page 72. Solid can easily change in volume. As you remember, we said that solid change volume. False, because a solid has fixed volume. Next, liquid takes the shape of their containers. Yes, liquid takes the shape of the container. Question 17, when the distance between gas particles increases, the distance here increases, the volume of the gas increases. Yes, when particles move away from each other, they take more space or they take more volume, and the answer is true. What happens to the kinetic energy of particles of a substance as substance changes from liquid to gas? What happens to the energy? Do you remember which one has more energy, gas or liquid? Yes, gas has more energy, so the kinetic energy, as liquid changes to gas, the kinetic energy of particle increases, because gas needs more energy to move far away from each other, and that's why they have more kinetic energy. Page 73, we have to match what solid. Solid particles are close together and locked in place. So we will match solid with letter A. B, liquid particles are close together and can slide. Particles here can a little bit move, and gas particles are far apart and can move freely. Question 4. What is the kinetic theory of matter? Do you remember this theory? That motion of particles in matter determines its state. The motion decides the state of matter, and the particles are always in motion. Question 5. What happens to the temperature of substance while it is changing state? When we said when water boils at 100, the temperature stays 100 until all the water evaporates. So the temperature stays the same. Temperature stays the same because energy is used to break the attraction between particles. So as we give more energy or more heat, the temperature stays the same because the energy starts to break down the attraction between particles, and that's why temperature doesn't increase. Question 8. First we will solve 8 and 9, and then we will solve 6 and 7, okay? This jar contains helium gas. What would happen if the lead here, if we remove the lead here of the jar, if we remove it, the lead of the jar, what will happen? Yes, the gas particles would escape. All the gas particles here will go out. Question 9. Explain how are the helium atoms in the model different from the real atom of helium? How is this different from atoms, real atoms? The gas particles are much smaller. The reality, we cannot see the helium gas particles. What could you do to change the volume of gas? How can you do this? You could put a gas in a larger container to increase its volume, like space. So put the gas in a bigger container and it will fill all the container. Question 7. Can a tank of oxygen gas ever be half empty? Can a tank of oxygen only half filled and the other half is empty? No, because the gas particles move freely and fill the volume of the whole tank. So you will never find half tank only, okay? Question 10. The particles that make up a rock are constantly in motion. The rock particles are always in motion. However, A rock does not visibly vibrate. Why we don't see the rock vibrate? What do you think this is? Because the vibration of the particles is too small, as we said, to detect by viewing the rock. The motion or the vibration is too small, and of course you will not see it only by your eyes. So this was everything for today, grade 6. See you in another video. Bye bye.